guys, my name is Shunya. I'm a credit risk consultant, and today we will be talking about the first test of hypothesis testing. In the previous videos, we've talked about how hypothesis testing is calculated, how it helps you statistically calculating certain things, and what it is and what are the bases of this statistical measure. Now in this video today we will be talking about the first test of hypothesis testing. It's a very simple test called the Z test. Now the Z test will help you make meaningful and statistical conclusions about your entire population based on a randomly selected sample that you've selected from that population. Now your sample should be greater than 30 and the population that you've selected for this test should follow a normal distribution. These are the prerequisites of calculating Z test. Now Z test helps you in calculating whether the mean of two populations is significantly different from each other if the variance is known and the sample size is greater than 30. Okay, now let's start. Now, in order to calculate the Z test, there are certain data assumptions that you must keep in mind. I think I've covered them also. That first, that the population should be normally distributed. Secondly, the samples that you have chosen should be independent of each other. Thirdly, the samples chosen should be randomly selected. The size of the sample should be greater than 30. And most importantly, mean and variance of the population that you are testing should be known. Now in the Z test, we want to know that the randomly selected sample, how far is it different from the entire population? Now I'm going to explain you with the help of a very simple example so that you are able to gauge where we are going at. You have a company in production of shoes. Okay, now what you do is that you want to test that for this year 2022, how are the sales different from what they were initially. So you have an entire population of the sales data points, throughout the history, and you want to check how different are the sales this year. So Z test will be very helpful because now you have a sample and you have a population and you want to check how different is the sample from a population. Now here on the screen you will see the formula of calculating a Z score. Z score is nothing but the population mean minus the sample mean divided by standard deviation of the population. So you are checking that how different is my sample mean from the population mean. And why are we dividing it by the standard deviation? Well, we are dividing it by the standard deviation because we want to make, in statistics, you have to calculate a standard difference. Now, this will help you. I'm going a little ahead, I'll come back to this, but just hear me out. That with the help of the Z square, you will be able to calculate your standard normal distribution curve. Now, what is this? Why are we doing this? Why is this getting calculated? Why are we dividing it by standard deviation? After we know that the sales in 2022 is this much different from the entire sales that we have had historically, we say that if we have to measure it, if we have to pictorially depict it, how different is that from my standard mean? Now, if you see the picture on the right, we've plotted a Z distribution curve where the middle point, the center point, has mean 0 and 0 variance, which means that if the data point or if your sample mean lies there, then it is no different from the population mean, and there is no variance between the sales that have happened historically and the sales that have happened this year in 2022. Now, if this data point lies to the right of my mean, which says, and say the value of the Z square is 1, which means 1 standard deviation away from the population mean. If it is the value of the Z square comes at 2, then it is 2 standard deviation away from the standard mean. Similarly, if the value that you are getting from the Z square is negative, you come to a conclusion that the shoe sales in 2022 are significantly different. Now, how much significantly different? How will we statistically measure it? That's why we divide it by standard deviation and we calculate how many standards, a fixed unit of measurement, it is different from the population. Okay, fair enough. Now, how do we calculate this standard normal distribution chart and why is it important? Now, you take different samples from your population, calculate z squares from the different population. Because your population is normally distributed, your standard normal distribution that is calculated, which is calculated from your z square, will also be normally distributed. But the only difference will be that it will be statistically placed at significant standards from the population mean. Which I'm like, let me put it more simply, it's becoming a little difficult. It simply means standard normal distribution tells you how many standards my population sample is different from how many standards my sample mean is different from my population mean by how many standards. That is what we're trying to tell in the standard normal distribution curve. Now, you have calculated your z square, you know where it lies on the standard normal distribution, but you don't know whether it is true or not. As we said earlier in my previous videos also, as I have said, that hypothesis testing is a statistical measure. Now, in order to check whether the value that you have is correct or not, or whether you should accept this inference or you should reject the inference. If you go back to our hypothesis videos where we've talked about the alternative hypothesis and the null hypothesis, so the z square value, whether this should be accepted or rejected, will depend upon the critical value. Now, here we are taking a test at 5% significance level, where as you can see on the graph, left side you have 0.025 and on the right side you have a critical area of 0.025, which together brings us to a 5% significance levels. We say that if my z-score value lies on the extreme end of these critical values, we reject our null hypothesis and we accept our alternate hypothesis. Correct? So this will actually help you in gauging whether your z-test value is accurate or not and why it is calculated. I hope you liked the video. In case of any further questions, you can drop us a comment. I hope you like, comment and subscribe, and I hope this video was helpful. Thank you